Welcome to the Supplying the Grid with Clean, Firm Power panel. I'm David Brown. I'm a faculty member here at Fuqua. I'm also the faculty director of Fuqua's EDGE Center, Energy Development and the Global Environment. I'm delighted to have the opportunity to moderate this panel. Three wonderful panelists. Let me just quickly introduce them by name. Akash Patel, Chief Financial Officer at Net Power and a proud Fuqua Daytime MBA alum of 2010. As we discussed, I did not have the good fortune of having to teach Akash, although I was at Daytime those years. Alex Smith, Strategy Manager at Fervo, doing some really exciting work in the geothermal space. And Eric Toone, Chief Technology Officer at Breakthrough Energy Ventures, also longtime Duke ties, including being on the faculty in the chemistry department. So main themes for this panel are how can future load growth be the economic driver behind private investments in clean solutions? And how do clean, firm tech companies demonstrate that they will deliver the clean, firm power needed to maintain corporate commitments? And so just a quick little preamble, and then I'm going to open it up to this fantastic group. So when we say clean, firm power, of course, what we mean are carbon-free sources of electricity that provide continuous power. This is in contrast to traditional renewable sources, solar and wind, which, while carbon-free, are intermittent. And so this is a really exciting panel for me, especially because something like a lot of other people I've been thinking about, how do we deal with the intermittency of renewables with like grid operators, doing things like AI-based tools for building better predictive models for net loads, smarter dispatch optimization. And so ironically, and we'll talk about this, and we talked about this morning, AI is actually exacerbating that problem, of course. And clean, firm power is exciting because carbon-free sources that could help mitigate this volatility. So if you continue with your great work, you'll be rendering some of my recent research less relevant or perhaps obsolete, but that's okay. That'll be a good thing for all of us, right? So let's start this conversation off. This summit is about investments, right? And so investment 101, think about valuing whatever you're investing in. And for me, you have to understand the fundamentals. And to me, the fundamentals here are the technologies. And these technologies that we're going to talk about today are really exciting. And I want to spend a little bit of time, before we can really understand the economics behind it and the market forces, we kind of need to understand those technologies a little bit under the hood. So I want to dedicate some early part of our conversation, some airtime to that. And then we'll pivot kind of the economic investment implications, maybe a little bit on policy. Lots of exciting things to discuss here. I've got Slido here. We've got so much to discuss. If we have time for questions, I'll take a few of those. Okay, so first question, and maybe I'll come to you, Akash, first on this. So as we foresee increased electric demand from in the US from hyperscalers, onshoring of manufacturing and sectoral electrification, there's been an increased need, focus on the need for clean, firm power. How do your respective technologies differ in approach to providing reliable carbon-free baseload power to the electrical grid? So can you talk a little bit about what you're doing at Net Power?
Sure. Well, first and foremost, thanks for having me. It's great to be here, and you're actually lucky you didn't have me as a student because I was a Section 4 table banger. So
I've had a few of those. They're entertaining. Yeah.
But look, I survived. So Net Power, a quick background on the company. The company's been around for about 15 years now, and the basic premise is this: you need clean, firm power, and the best feedstock for that can be natural gas if used appropriately. So let's disconnect the fossil fuel from the problem, which is the CO2, right? So the basic premise of the technology, and I won't get into thermodynamics and the great benefits of supercritical CO2, but our system breathes natural gas. It generates 200 to 250 megawatts of electricity per module and inherently captures all of the emissions. So no SOx, no NOx, no CO2. The CO2 is captured inherently by the system. It's pipeline quality and specification, and then can be utilized for straight sequestration via Class 6 in the US or via Class 2 for enhanced oil recovery. That's the basic premise of the technology. So what have we done in the past 15 years? We went from the idea of Net Power on paper through engineering to actually developing a demonstration plant outside of Houston where we proved the technology works. We proved the process of the technology. You can combust natural gas in a supercritical CO2 environment, create electrons, and inherently capture all of the emissions. So what is next for Net Power? Next is commercializing the technology to its fullest potential, which means we are taking our demonstration plant, which is about a 5-acre facility, 50 megawatts of thermal input, and we're now scaling that up by about 10 times. So the first large-scale facility will be about 550 megawatts of thermal input, 200 some megawatts of output. located on roughly a 15-acre site. So, we'll talk about a lot of the other attributes that make Net Power unique or interesting, and the energy density and ability to site, because you don't have emissions close to demand centers, and also just the pure nature of having 15 acres for 200 some megawatts is pretty interesting. The other attributes include the ability to not only do firm base load power, but also load follow, so ability to ramp up and ramp down, and also peaking. So to the extent that's needed, we can also peak above our nameplate capacity of 200 some megawatts to service the grid needs. So over the last 15 years, we've raised over $1 billion. Surprisingly, even though the premise of this conference is really government funding and how that translates to accelerated private capital, Net Power has not taken any government funding to date. That is obviously something that we consider, but we've been able to fund to date via private capital alone, and so we've done various funding rounds, and the company's 80-some% owned by large strategic oil and gas, utility, and OEM manufacturers. I'll pause there.
No, that's really interesting. Can I just ask you to elaborate a little bit on, there are other players in this space, the natural gas combustion, CCS. I think Exxon's doing this too. What makes your technology special?
Yeah.
Just distinguishes it.
Yeah, so the basic science lesson, right? And I'm a dumb finance guy, so pardon my not getting the chemistry perfect. But in traditional gas generation, what you do is you take natural gas and you combust it in air, right? You need air because air has oxygen. 20% of the air is oxygen, while 80% of it roughly is nitrogen. The combustion of natural gas with oxygen creates three things. It creates a bunch of energy, which you can use to turn turbine blades and create electricity. It creates CO2, and it creates water. The problem is, in traditional combustion, that CO2 you created from the combustion mixes with the air, which is now entirely nitrogen. And separating nitrogen from CO2 is very expensive and difficult. And so up until now, the world has been trying to optimize and increase efficiency of gas-fired systems by solving for one variable, which is increase the power output. We don't care about the CO2, right? And so now if you go and try to do post-combustion capture, it's, again, expensive and difficult. What we did was turn that on its head. We said, what if instead we redesigned the system with a blank sheet of paper and solve for the carbon capture on the front end? So what did we do? We've replaced all of the nitrogen in the air with the synthetic air, which is 80% CO2 and 20% oxygen. And so now when you combust natural gas with our synthetic air, you still create a bunch of energy, CO2 and water, but the CO2 you created is now in a CO2 environment. There's no capture needed. So if you solve for it on the front end. And that's how our system is a little bit different. And so when you think about post-combustion systems, yes, it can be done. The engineering allows you to do it, and you can get up to probably 95% capture, and you can go higher and higher, but it becomes increasingly more expensive and difficult as you incrementally improve upon that. Our system inherently captures all of the emissions. And so, we claim to be 97% capture, but that's really because there's fugitive emissions from seal losses. As long as you improve those seal losses, you can get to 99.9% capture, which is the pathway of what we plan to do.
Okay, that's helpful, thanks. And you convinced me on the science, although I'll defer to the chemistry professor on our panel here. So, all right, Alex, let's come to you. Fervo's doing some really exciting work in the geothermal space. Can you talk a little bit about your tech there?
Yes, so Fervo is a next generation enhanced geothermal systems developer. So what the heck does that mean? I'll start by explaining how traditional geothermal works, and then we'll get into how Fervo's technology differs. So to produce geothermal power, you need three things. You need hot rock, you need some sort of fluid to flow through that rock, and then you need some path for that fluid to flow. Traditionally, and I say traditionally, geothermal, the industry itself, has been around for many, many decades. Traditionally, developers will site in locations that have existing fracture networks in the subsurface. So they are actively looking for areas that have hot rock, existing fractures, and then what they will do is drill a production well, or an injection well to try to intersect those fractures. They will also drill a production well. Then they will pump fluid down the injection well, through the existing fracture network, up the production well, and that hot geothermal brine will vaporize and run a turbine. The reason that this has some challenges is, as I've mentioned, you are geographically limited to areas on the Earth that already have kind of that sweet spot of this existing fracture network, hot rock, ideally some fluid pack systems. You've seen this in Iceland, you see it in the geysers in California, but it's pretty limited geographically. The bigger challenge here, though, is that existing fracture network that is in the subsurface, that can be somewhere between 5,000 to 10,000 feet deep. And it is really, really hard to model, and it's impossible to control. You get what you get. And so we've seen time and time again where these developers will go out and they will start pumping their fluid into this system. And instead of seeing the hot brine return to surface to generate power, it will actually dissipate into the reservoir. This is considered a dry well or a dry hole and happens on average 1 in 3 wells in traditional geothermal. So that kills the project finances, that makes it really hard to get investment, and it has been the primary reason that geothermal is less than 1% of the grid today. How Fervo's technology differs is that we actually engineer this subsurface fracture network. So we take horizontal drilling and fracking techniques, off-the-shelf technologies from the oil and gas industry, and we drill our own, we drill horizontal wells, 2 of them, and then we will frack to connect them. So we basically create this subsurface heat exchanger on our own. This allows us to site in locations that have hot rock, so it's much, much more geographically abundant. But even more important, it gives us significantly more control on the success rates of the projects. You move away from this binary, it worked or it didn't work, to more of a good, better, best sort of scenario. And you have many more levers to pull to make the projects economic. To date, we have demonstrated this technology at pilot scale, or at commercial scale, at our commercial pilot in northern Nevada. This is a 3 megawatt system that's been online for over a year. Looking good over there. We are actively in construction for our first commercial scale project in southwest Utah. This is a 500 megawatt project where the first tranche of which will come online in 2026.
And you also have something with Southern California, or is that?
That is selling to Southern California, to Southern California Edison,
just
yes.
To understand this a little better, this could be a game changer. Basically, we think of geothermal as basically where geysers are, just very loosely, right?
Yeah.
Probably a little bit of a simplification, but am I understanding correctly? Essentially, you could maybe get geothermal almost anywhere, potentially.
Yeah, so with the drilling capabilities we have today, and it's purely a game of economics, how fast you can drill to the depth that you're trying to access that heat. The entire Western United States is economic today. There's other siting considerations, largely around interconnection. That's more of where you have to focus. But yes, the entire Western United States would be economic today. We are going to continue to drive down drilling costs, drive down project costs, and as you see that, then we'll be able to move move east.
Okay, very, very interesting. Okay, Eric, let's come to you. Breakthrough has, I think, more than 120 companies in your portfolio now, so there's a lot of different directions you could take this, but maybe talk about some of the most exciting clean firm power technologies, in your view, complementing some of the comments earlier.
Well, if you think about sources of energy, we have exactly 3 sources of energy. We have the energy that reaches the Earth from the sun, we have the energy that's contained as heat in the Earth, and we have nuclear energy, in which very small amounts of mass are converted into energy, according to Einstein's famous formula. We just heard about geothermal. There are important intermittencies with solar energy, whether that's solar, whether it's wind, whether it's hydro, all of those things have important intermittencies in them. So if we're talking about zero carbon firm power, the vast majority of zero carbon firm power that's produced today, about 10% of all electricity globally, is from nuclear, right? So nuclear fission, we were pretty good at building. There was an enormous amount of nuclear fission that was built out in the 1960s and 1970s. And then, of course, we have 3 Mile Island, and people come sort of face to face with the challenges of nuclear fission. And broadly, there are three wastes. The wastes of nuclear fission are radioactive for millennia, and so there is a storage issue. There is a proliferation challenge, and some of these products can be weaponized. And then, because nuclear fission is a chain reaction, there is inherently the problem of runaway reaction and safety. So the cost of building out nuclear fission rose roughly fourfold after 3 Mile Island, and they continue to rise. Having said that, we really know how to manage the risks associated with all three of those issues. Rather, the challenges that we have today are cost. We don't build nuclear fission because it's just too expensive. And most of those costs are imposed by regulatory aspects that surround nuclear today. And so I think that we've got to revisit those regulatory issues. I'm sure a lot of folks in the room here today have read Ezra Klein's new book, Abundance, that discusses these issues, how we become sort of sclerotic around the fear of potential dangers. And I think we have to revisit those. We have reactors that are much safer than the reactors that we built at that time. We have ways to deal with all of those issues, and nuclear fission is the way that we produce clean, zero carbon, firm power. And so some aspect of it, I think, is going to have to revisit fission. There are all sorts of other challenges around fission. We've lost the workforce. We don't know how to build the reactors anymore. And that became very apparent at Vogtle in Georgia, for instance, where a very significant part of the cost overruns were just issues with the fact that we don't have a workforce that knows how to build reactors. So getting back into the reactor building business, I think, is certainly a piece that we are going to have to do. The other way to do nuclear energy, of course, is fusion. And in fusion, we take two light nuclei and fuse them together to produce a heavier nucleus. Fusion avoids all of the challenges, the safety challenges with nuclear fission. The products are radioactive for decades rather than millennia. The products, for the most part, can't be weaponized. And because it's not a chain reaction, it's inherently safe in the sense that you can't have a runaway reaction. The challenge, of course, is how you overcome the enormous repulsive forces between nuclei to actually result in fusion. And so this has led to a number of science and engineering challenges, and people sort of, the old joke is fusion is 30 years away, and it always will be. I'm here to tell you that that is simply not the case. There are many ways to do fusion. The most advanced has to do with magnetic confinement. That whole field took an enormous leap forward with the development of high TC superconducting magnets that allow you to massively shrink the device. So you no longer have to build things that look like ITER. One of our portfolio companies, Commonwealth Fusion Systems, is building their prototype device today. You can go to Massachusetts, you can see it, you can see the 12-foot thick concrete walls. All the magnet segments are built now. That will be producing energy next year. It is not 30 years away. They have already signed a license for the site for their first commercial reactor in Virginia. And there are many other approaches that are coming to fusion, and other approaches to magnetic confinement, so Stellarators, Type 1, another portfolio company, but there are many other approaches to fusion as well, Z-pinch and things like that. So fusion, I think, is one that we have to be realistic about. Still challenges, but this is not something that is 30 or 40 years away. So nuclear power is going to have to be a big part of clean, firm power. And then, you and I were joking the other night, the issue with solar, of course, is intermittencies. And some of you probably heard me talk about those intermittencies. They range in time domains from seconds to decades, and they're very, very challenging to address. But one way that you can avoid all of those intermittencies is to collect the solar energy in space, space-based solar. Space-based solar, even 10 years ago, was sort of tinfoil hat level lunacy. It's not today. It's not today. In the mid-1980s, when we were launching the space shuttle, it cost about $50,000 to put a kilogram of material in space. Today, that number is 500. and it's still dropping and dropping rapidly, perhaps as low as $100 a kilogram. And so all sorts of things that were tinfoil hat level lunacy not very long ago are all of a sudden potentially realistic alternatives. So both NASA and the European Space Agency are looking at the possibility, the potential of space-based solar. And I still think that, you know, it's probably more likely than not that it doesn't work, but this is not nuts anymore.
So once the economics are there, you say go for space-based solar, no question in your mind?
Sure, yeah, absolutely.
Yeah?
I mean, there are lots and lots of challenges.
Yeah.
You know, are you going to make electricity there and beam electricity back?
Right.
Are you going to beam energy? Like, I don't want to minimize the challenges, but there's a very significant commercial effort at Caltech now. And there are a number of other companies that are forming around this.
Fascinating. Let me ask one quick follow-up tech question, then let's come to investments. So long-duration storage, I sometimes see that lumped in with clean, firm power. I know you have some investments, like Fervo Energy is doing 100-hour iron air batteries, very exciting. Is that clean, firm power, or is this maybe a semantics question, or is that, I mean, storage is super important in long duration for that intermittency challenge. How do you view that?
You know, the challenge with intermittency is that it's the time domains that are involved. So there are intermittencies that happen over time domains as short as seconds to minutes. A cloud goes over my solar panel, something like that. And then there are time intermittencies that happen at much, much, much longer time domains. So for instance, seasonal intermittencies, right? Solar insolation in Northern Europe is 5 times in the summer what it is in the winter. There's an inverse correlation between the length of the intermittency and what you can afford to pay for it. So if you have, and one way to think about this is if I have a very short time domain intermittency, how many times do I get to amortize the CapEx over? So if it's a short time domain thing, I use it multiple times a day, and I get to amortize that over a lot of cycles. If I want to deal with seasonal storage, I get to use that asset once a year, right? And those intermittencies go over even longer time domains. So Brazil, for instance, 70% of electric generation in Brazil is hydro, which we think of as baseload power. But a decades-long drought means that hydro goes away. And when that hydro goes away, how do they respond? By burning coal. There's intermittencies that last even longer than that. So these very, very, very long time domain intermittencies are a real challenge to deal with.
Thank you. Let's come to the investment piece. This is really about private capital, right? And if you think about clean, firm power, this is perfect material for private capital. You have often relatively high upfront capital requirements. You have technologies that by construction are, less proven. So you're going to need investors who have higher risk tolerances, appetite for longer durations, a little bit more patience with lower liquidity. And maybe I'll start with you, Eric, on this, since you're dealing with a lot of investors in your work. What are you seeing regarding interest from private capital in investing in your technologies broadly in the clean firm space? And how is that maybe evolving?
Sure. So there are a lot of investors, large institutional investors. So our capital comes from 2 groups, ultra-high net worth individuals and then institutional investors. At the beginning, it was all ultra-high net worth individuals. Now it's probably even more institutional investors than ultra-high net worth individuals. You definitely need people that have time domains that are long, and you definitely need to have people that have a high appetite for and tolerance for risk. But as I mentioned, Commonwealth Fusion Systems has raised over $2 billion now, and that didn't come from venture. That comes from institutional investors. And so there are absolutely folks out there who have interest in those kinds of challenges and have tolerance for risk. We absolutely, positively need new forms of capital. We need new models, new approaches to deploying capital. We've been talking about this a lot, and somebody pointed out to me, the challenge isn't that there's not enough money around. There is lots of money around. The planet is awash in money. Apollo Global Management takes in $1 billion a day. So the challenge is not capital. The challenge is a model to put that capital to work in a way that the investors are rewarded appropriately for the level of risk that they're being asked to take. And so there are a lot of smart people now thinking about how you can put pools of capital together that would allow you to tackle some of these risks. So for example, suppose you pooled enough capital to build 10 first-of-a-kind reactors, and then everybody got the average of what it costs to build each of those. So as you come down a cost curve, so nobody pays the first of a kind, nobody pays nth of a kind. There are a lot of smart people thinking a lot of interesting models to put that capital to work, and we absolutely need a lot more of them.
That's great to hear. So Alex, what are you seeing? Fervo's privately held, but I've looked at your investor list, super impressive. A lot of folks really excited about your technology. What are you seeing on this front?
Yeah, so I think I would echo a lot.
One down there.
Yes. We've had a pretty strong track record of being able to raise, venture capital, corporate level equity, and we've had some. I think what's really cool about our capital stack is that it's a very diverse set of investors, right? You have some of the leading climate tech investors, along with a lot of the incumbents in oil and gas, for example, and so that has been really strong. We've been, moving forward there. We are now, executing. We're in actual construction with our first of a kind project in Southwest Utah. So we need to start accessing this, cheaper capital. We are looking for, project financing / debt. And I think there's still a ton of appetite there. We are seeing a lot of traction, but it is definitely harder. And then, add on the last couple of weeks of, uncertainty, and I think even the appetite of investors may be changing. But overall, I would say hopeful.
But I think this is a great example of an area that needs new kinds of capital. Maybe you could talk a little bit about the challenges of finding investors who are willing to assume the downhole risk.
Yeah, I think so. It's both the downhole risk, but it's also the lack of understanding of the industry as a whole, right? It's an industry that has been around for many, many, many decades. So some investors will look at that and go, that's boring. You're not risky enough, almost, right? We've done that. And then you'll have another set of investors who understand that we're, trying to deploy this new form of geothermal. It's a different type of technology, and they'll see that as all technology risk, and they'll be very concerned and consider that very high risk. Realistically, it's just a resource play. It's very much the risk. At this point, we have de-risked the technology, and the risk is very much on execution, and it's a risk profile that looks a lot like oil and gas. It's all about a resource risk.
Yeah, and this is the natural life cycle. If some of these projects keep taking off, 400 megawatts in Utah, you're going to be able to lower that cost of capital, right?
Yeah.
Akash, I know Net Power is publicly traded. That said, you do have private investors. Yep. I read about the PIPE a couple of years ago. What are you seeing on this front?
Yeah, so, Net Power, what we're trying to do is exceptionally ambitious. It's a new type of engine. It's a new power generation system. And very early on, we came to the conclusion we can't do it alone. And so how does a little startup technology incubator actually change the world, right? Because we inherently believe the day the first plant turns online and you've used natural gas, generated electricity, and captured all the emissions, you've changed the world. And so the path we took was you have to have long-term strategic partners, right? So we didn't really go after VC money. We went after corporate sponsors, right? So we had an EPC first invest in the company back in 2010. Then there was Exelon, now Constellation, that invested in 2014, and then Occidental Petroleum, the largest actually user of CO2 in the world, invested in the company in 2016, and then increased their investment pretty materially in 2020 when we went public. And then you have the Rice family, which spent their entire careers in the natural gas space and understand the sector. So you have oil and gas. You have an oil and gas company. You have a natural gas entrepreneur investor. You have energy, a power generation utility. And then the last piece of the puzzle for us was we needed the OEM. We needed who was our rotating equipment provider, and are they going to be a strategic investor? And that's when Baker Hughes came into the capital stack, and they provide our rotating equipment. And so, like for us, it was a very tactical approach to getting long-term strategic investors to be all part of the capital stack, which solves a problem of making sure you have sticky folks, but also, more importantly, solves a problem of access to experts, right? We can't solve every issue we have. We need to rely on folks like Oxy and Constellation and Baker Hughes to provide us their expertise when we need it, which is really critical. And I think that goes to where we are headed, right? So I think we are, the textbook of, in the valley of death phase, or what they call it, right? Like, we have $500 million of cash on our balance sheet, and we are very, very cash rich to develop, improve our technology. But when plants cost billions of dollars, where's that money coming from, right? And so we are selling a reality, not a dream at this point. And how do you overcome that hurdle? And the way you overcome it is with partnerships. Again, it comes back to, you can't do it alone. You have to, whoever shares the risk is going to share in the upside. And that's how you have to structure every one of these transactions to raise capital or to do offtake, et cetera.
Yeah, and the diversity of the investors you're citing there is just a kind of a strong signal about how powerful these market forces really are. So let me ask a question that maybe kind of blends the first two questions, both about the tech side and the economic side, and I'll open this up to whomever wants to start. So where do you see the most promising convergence of technologies that could accelerate clean, firm power deployment, and what are the primary barriers, economic or are they tech? And we can't really disentangle those things completely, of course, they're inextricable, but how do you see that? And whoever wants to start here.
I think that there is huge potential. We've talked, so if you want to know, the nearest term approach is absolutely getting back to building fission. But if we take that off the table, I think fusion, again, is closer than people think it is. And there's clear demonstration for appetite for the risk and tackling the technology. I think geothermal is incredibly interesting, but I think geothermal has to go to higher temperatures, to significantly higher temperatures. You get above 400 degrees C, and you're cost competitive with combined cycle natural gas. And that, I think, are the sorts of places that we're going to have to go. I think the environment that we're moving in now, there's going to be a much greater pressure on zero green premium and on developing technologies that can be cost competitive, without subsidy. And so I think that those are the kinds of technologies that can achieve those goals.
I will make one comment on the cost parity with natural gas. So for our first of a kind ever project, you're looking at around $6,000 per kW, right? That's the most expensive it's ever going to get. We are already pushing down. We're making huge strides on this. Where the improvements have come historically is our drilling. We have, from the first well to our most recent well, cut drilling costs by about 60%. Why this matters, traditionally, geothermal, about 80% of the capital goes towards the subsurface, and 20% is the power generation equipment. Because of the improvements we've made in the drilling space, our capital structure now is 50% in the subsurface and 50% in the power generation space. So our eyes are now looking over at the power generation equipment. And how can we, drive down costs there? Again, none of this is a technology risk. It's all equipment that exists today. We just need to, find modifications in piping and find ways to prefab and kind of the boring incremental changes that will have huge impacts on our cost. And we are driving towards a 3,000 per kW capital structure, which is cost competitive, or actually beats natural gas.
Yeah, I couldn't agree more with both of your comments on this. I actually would turn it on its head, and I roll my eyes sometimes when I say this because I hate being so cliche, but it takes there's no picking winners here. We need every technology we can get that can drive and be economic, right? Economics will ultimately prevail, right? There's government incentives and policy things we could do to help facilitate that, but ultimately, how much of a premium is the full market going to be willing to pay for a clean, firm electron versus one that is unabated and cheap, right? So I think economics will ultimately prevail. And there's going to be areas where geothermal is going to make the most economic sense. There's going to be areas where fusion is going to make the most economic sense, well, probably anywhere, quite frankly, if you get the cost down, right? Once you deploy it and scale. And then there's things like Net Power, where yeah, we do need access to natural gas. The cheaper, the better, and you need access to somewhere to put the CO2. Geology suitable for sequestration. Luckily for Net Power, 80% of U.S. power demand is within an area that is suitable for sequestration. So where are we focused? The deregulated markets that have those two things, right? That's PJM, MISO, Northern Southern, that's ERCOT, that's SPP, that's CAISO, that's Alberta, ISO. So but if we do have folks that come to us that are interested in learning about Net Power, and they're interested in doing something in Florida or in North Carolina or in the Pacific Northwest, and we say, go look at SMRs or go look at some. We can't do it there because the geology is not suitable for it. So it's not about any one technology. It's about all of us figuring out where it makes the most economic sense to go and drive down costs.
Yeah, and to that, the renewable example, you can lower the cost of solar and wind as much as you want, but if you don't have storage technology to time shift the energy, it's only going to go so far. All right, we only have a few minutes left, I think. Let's pivot a couple minutes, talk a little bit about policy. Obviously, we've touched upon this in some of the other panels. World has changed a lot in a few months, and since last year, since we ran this event. If you're going to be in the energy sector, transition risk, that's just part of the story. What policies overall do you think could spur investments in clean, firm energy? And anyone want to start?
How long do we have?
Give us a quick thought or two.
So
I can't actually see the clock.
Look,
we have 8 minutes. Okay.
I think I'll tackle this one slightly different than really talking about just the government response and policy there, because I think we can all agree that there's a lot of things that could happen. I think one of them is the fact that you could build the Hoover Dam a year early and under budget, but you can't get a permit, right? We've gone from a country that was really good at building things to being a country that is really good at saying how not to build things. But to me, the bigger, permitting aside, I think one of the bigger things is how do you create the even playing field, right? The government's job is not necessarily to pick winners, but I think we're going to have to at some point. But there's plenty, I think, that you can do. But I think it's been well covered all day. I think we saw a lot of the experts, over the past several, panels talk about all the things about 45Q and 45Y and tech neutral credits.
Yeah, Alex, I've heard your CEO and founder, Tim Latimer, is that his name? Yeah, so he's talking about geothermal going up from under 1% to 20% of total grid generation capacity, which is mind-boggling. I mean, you may just be able to get there with private investment in your technology just proving itself, but what do you think on policy side could help nudge it faster?
Yeah, I think first and foremost, protecting the IRA. As it stands right now, the PTC and ITC, our returns do not necessarily depend on this. We will still have a business, but it accelerates. It really gets that flywheel going so that we go from 1 gigawatt to 20, or much, much faster. And so I think that is one of our core policy areas. It's really, really important for the industry to continue to accelerate our growth. I think the other area, and it's similar to what you were talking about on permitting, it's, basically reforming NEPA permitting, getting geothermal categorical exclusions that match and create more parity with the oil and gas industry. Right now, we trigger NEPA significantly more frequently than you see in oil and gas, and that just causes uncertainty, can cause delays, it causes a lot of administrative burden on the companies, and so we do need to focus on that area as well.
Eric?
Yeah, so ditto for sure on the permitting, on all of those things. I think that we are big fans of tax incentives and subsidies that help put things on a learning curve and drive things down learning curves. I think there's little support for long-term subsidies to prop up on economic technologies. I don't think especially in the universe that we're headed into now, that those are going to exist. So I think new approaches to tax credits, new approaches to capital that protects investors' first loss capital, helps folk, things like that, and puts technologies on a learning curve to find out what their ultimate cost entitlement is and to get them to that point as rapidly as we possibly can, because I think they're going to have to ultimately be cost competitive in an open market without subsidy.
That's exactly, that was exactly the point. It's the credits are fantastic and they're the training wheels, but economics will prevail. And so these technologies need to get down the cost curve and be competitive.
So maybe last couple questions here. Maybe we don't have the policies that would be ideal, that we, in an ideal world right now, but we can also think about cross-sector innovations and collaborations. And what do you see emerging kind of in the clean, firm power landscape? And maybe, Alex, we could start with you. I know a lot of fanfare on the arrangement with Google, the big power purchase agreement. I know you can't chat too much about it, but maybe high level, other kind of innovations, other partners, tech companies, a lot of interest there.
Yeah.
Thoughts?
Yeah, definitely happy to talk about that. So there's a ton of interest, for EGS from the hyperscalers. We have a publicly announced PPA with Google. It's actually a sleeved PPA, so it is we sign a contract with the local utility who signs a contract with Google, so that's a way for corporates to procure, clean firm or clean energy renewables. And it's a pretty good model that many states have access to. But how this kind of impacts the future, this insane growth of AI and incredible demand from the hyperscalers, that type of demand does spur investment and growth of these new technologies. I can give kind of an example. In 2021, the California Public Utility Commission mandated the midterm reliability ruling, which required 1 gigawatt of clean firm procurement into the state. And immediately after that, we started signing some big PPAs. So and that is the reason for our project in Southwest Utah.
Edison.
So the demand signal has a huge impact on getting these projects off the ground. Yeah.
People, economies, societies decarbonize as soon as they can afford to, right? As soon as the choice is no longer between prosperity and green. And so that's why you see companies like Google that are so willing to participate in this. I have to make a big plug here for figuring out how we deploy these technologies in the developing and emerging world. Because there is a choice to be made between prosperity and green, and it's not a difficult choice. They are going to choose prosperity. Energy absolutely positively is prosperity. The discovery of just enormous natural gas resources in Africa, possibly as large as in North America, they are 100% going to use that natural gas. And telling them not to is a fool's errand and a waste of time. If there's a way to deploy something like net power that can allow them to access that resource and use that resource, these are the kinds of things that we really have to do. Energy is prosperity, and if people are forced to make that choice, it's going to be a really simple choice. Economies decarbonize when they get rich enough to be able to afford it.
Akash, any thoughts on unexpected collaborations, cross-sector innovations?
I mean, I think you both covered it pretty darn well. I agree, energy is life, and I don't know if folks follow Doomberg or Jim Worthy, but he has some really good points. They both have some really good points on exactly what you said. We are the lucky billion, and we consume about 13 barrels per capita between the US, Canada, Europe, Japan, Australia, New Zealand. And then there's 1.5 billion people in China, 1.5 billion people in India, 1 billion people in South Asia, and 1 billion people in Africa that all consume less than 3 barrels per capita. There is going to be more consumption. Even if they double and we cut in half, there's still going to be a ton of consumption increasing in oil and gas. And so it has to be used responsibly across the world because energy is life. Humanity organizes itself on extracting and exploiting energy. It is the standard of living improvements, and the only way that's the way humanity organizes.
So I'm being signaled my 1 minute, I guess, lightning round question. There were a few questions from the audience that's related to one. So this is just quick to address this. People think these new technologies, okay, they help solve some energy problems, but they create other problems potentially. So how do your technologies address broader environmental concerns, water usage, land impact, potential ecological disruptions? Obviously, it's a broad question to end on, but maybe I'll start with you, Alex. Obviously, when people are thinking geothermal, hydraulic fracturing, there's a concern there, but I know you're very thoughtful about this, so quick chat on that.
Great question.
Yeah.
First of all, EGS uses no fresh water at all. The water we use is all very, very high total dissolved solids. It's the type of water you cannot use for agriculture, you cannot use in your communities. You get it from a deep saline aquifer. We also deploy a certain type of power generation equipment that is a fully closed loop. So even that dirty water that we are using, none of that gets evaporated into the atmosphere, so it is all a fully closed loop. The only area in our process that you'll see water leak off is in the reservoir itself, so it's being moved from one part of the reservoir to another part of the reservoir. And you'll have small amounts of makeup water to do that. And then as far as footprint, sorry, I'm talking very fast. As far as footprint, geothermal takes up, less than 1/5 to 1/10 of that of solar. And so the footprint is, and that is of our first of a kind. We are continuing to drop that footprint even smaller and smaller. So, yeah, good question though.
Eric, any thoughts on that? I mean, I've heard you talk about nuclear. We've really just kind of lost our muscle memory in the U.S., particularly since 3 Mile Island. I mean, it's just thoughts on kind of broader, environmental impacts and things like that. I mean,
well, look, the notion that there is a technology that is impactful and provides energy to billions of people and has no environmental impact is just, it's not realistic. And so if that's the bar you're going to set, then people are going to burn coal and natural gas.
Right.
Full stop. And
right.
so, I think you have to be realistic and accept that you cannot do things at the scales we're talking about doing here and have no environmental consequences. So the name of the game is to minimize those consequences, not take them to zero. And so I think a lot of the technologies that we've talked about here today do exactly that.
I think I've been told our time's up, but Akash, quick parting thoughts on that?
I agree. Look, we have a limited land footprint. We're thoughtful about things like engaging with communities early and often to make sure that, just because we're doing what we think is the right thing for the environment doesn't give us a license to operate without having full engagement of the local communities. And so that's really critical. But look, regardless of if it's, post-combustion capture or net power or geothermal or nuclear, there's going to be an NGO that comes out and says that we're doing something that's not great for the environment. And so just remember, perfection is the enemy of progress, and we're all headed in the right direction.
Thank you so much. Fantastic panels. I've learned so much. Thank you so much.